Hi guys, I hope all you are doing great and thank you for tuning in with Recro. I am Sarthak, working as a software senior engineer at Dunzo and a part of Recro, which is a developer focused organization where we are trying to connect developers' aspiration to the right opportunity by working with the high growth startups such as Dunzo, Swiggy, Kyofit, Udan, and a lot more similar startups. And today we have our speaker who is Himanshu Singh, and he's a Google's developer expert in Android, and he comes with a 4+ of experience, and he had worked in organizations like Ruby. So he'll be giving us a talk on the latest Jetpack Compose, which is like the new library that Jetpack has given us recently, and until recently, it is open for use also. So I'll give my baton to Himanshu and for him to start this session.
So the title basically you all know that it's compose your app. So we have been designing a lot of UIs, let's say Android applications. We have linear layouts, we have recycler views, and a lot of different UI components, right? But eventually, what we do is we actually design our applications in such a way that we have to write a lot of XML code, and just to bind that with our current application, what activities and fragments we used to bind it using find view by ID. Then Google came up with called view bindings and a lot of new stuff, right? So telling you to a point, some people actually come up and say that why we need to actually start off with a certain application thing in XML and again learn Kotlin. We can actually do the same thing with React and as well as with Flutter, because we just write the code in Dart or JavaScript and everything is done, like right from inflating the layout to actually designing your applications to populating certain set of data, right? So it's just that what I wanted to mean here is it's giving you a single source of language paradigm. You don't have to learn XML, you don't have to learn Kotlin or Java per se, but you just need to go and understand either JavaScript or Flutter, and then you can just build up your application, right? That's the whole fair bit how Flutter or React Native works. So I would call them as declarative UI. So in that, only one language is used, and you can use it for designing your whole application, right? So a year back, Google came up with a solution for native Android developers, correct? So it was actually named as Jetpack Compose. So Compose is that replacement, I would say, or not a replacement, is a solution for Flutter devs or React Native devs who still want to do Android applications in native development using Kotlin. So at that point, I would say using just Kotlin, you can actually design your UIs, you can populate some data and whatnot. So basically in this talk, we are going to see what all possibilities we can actually perform with Jetpack Compose and how you can actually get started with it. So before starting that session, I have to give a basic intro, which Sarthak mentioned. Who am I? So basically, I'm a Google developer expert for Android. I am an open source developer. I have a couple of libraries made on my end. I like to open source newer set of architectures which I design. So in my GitHub, you would see there is one sort of library which I have built using Jetpack Compose and all. Apart from this, I am a speaker, blogger. So anything which depends on the community side, I love to contribute my end there. So on a community, I like to go as a speaker. This year has been a COVID year. So that is the reason I have been doing everything online, but I love to go in person and deliver talks. I write certain blogs, which you can find on Mindocs. I have been blogging there for quite some time. And apart from that, I work as a senior Android engineer at Rumi. So that's pretty much about me, what I have been doing till now. Rest all, if you want to find, you can follow me on Twitter to see all the activities I have been doing recently there. So going to the agenda, what we have for this specific talk. The first is we need to understand Jetpack Compose. That's pretty much the basic thing. Why we need it, what is Compose, and what we are doing with it, right? Second is, this is not actually something I wanted to keep, but this is for engineers who like to see how things work. So basically, when we go for an interview nowadays, a lot of questions are at a certain aspect where people ask how recycler view works internally, or let's say how Dagger works internally. So rather than using it, so let's say that Google launches something and you come up with a solution that let's use it for, let's say, Dagger Hilt, for example, right? I don't want to use just Dagger Hilt. I want to understand what Dagger Hilt is giving under the hood, which we couldn't do earlier. So my point is, I would be explaining you in bits and parts what actually Jetpack Compose does. Correct? That's the second agenda what I have. Third is, I would show you certain set of codes how to write and how to work with Jetpack Compose. So here, I'm again saying this, I would not be using any XML layout. I would just use Jetpack Compose. That's it. And at last, I would be giving you a difference between XML layouts and a Compose layouts. So that's a pretty much comparison and a certain ways and a use case where I would say where you can use all of these like Compose or where to use XML. So it's basically certain trade-offs of using Compose and a certain trade-off of using XML. Me personally, I don't like designing UIs. The reason of it is a lot of designers come up and say, right, that we need a pixel perfect UI. But at certain points, having a lot of different phones, I would say, making everything perfect makes no sense. But I feel with Jetpack Compose, it has become easy because now it is statically combined with that part. So that's something which I feel is very good with Jetpack Compose. So that's something we are going to do. So without any delay, let me start with Jetpack Compose. So I would not stop here right now for any questions, but I would ask a lot of questions in between. And I hope you guys reply in the chat so that this session actually becomes much more interactive. Because my point is, for me, it feels like I'm just speaking in front of a computer, but whereas I know that you guys are actually watching me there. So it's always nice to have an interaction going on from both sides. If you have any questions, just shoot and I'll try to answer while in the chat if it's a good one, correct? Or else we'll take it in the Q&A. So let's first understand what's a Jetpack Compose, correct? So I gave you a basic overview, but the basic text view definition is it's a UI toolkit for Android. So when I say it's a UI toolkit, it's just like a newer set of designs which Google has said it is a good way. And when I feel this, because when Jetpack Compose is here, I definitely feel it might actually replace XML in the future. I'm not pretty sure, I'm not commenting anything. But Google coming up with this something because first they published Kotlin. A lot of Kotlin libraries came, like Flow, coroutines, and now Jetpack Compose works seamlessly with coroutines, correct? So this is just another toolkit. You can still do a lot of things with XML. And if you feel that your problem is actually solved via XML, I would recommend you should not be using Jetpack Compose. But at a certain stage, it's always nice to upgrade yourself. So this talk you can consider as a upgradation part for yourself, but just keep on learning. And yes, Jetpack Compose is not yet ready to be in production because a lot of breaking changes has to come. Second, Jetpack Compose helps you replace your XML code with Kotlin. So a lot of Android developers, I suppose, have already moved their code set to XML, to Kotlin, sorry. So there are some legacy set of codes which are still in Java, but developers are actually working towards it to remove it, right? Kotlin has been there for quite a long time. So what if we can actually replace the XML from the Kotlin itself again? And yes, if you know Kotlin, making UI makes a lot of things easy. For me, XML was also easy, but I don't like XML because it's just boring for me. I don't like the things which I have to do for UI. So with Jetpack Compose, a lot of things come up in a very better way and a very easy way. It becomes very lenient for me. So that's all about Jetpack Compose. So this is a very basic example, I would say, how you can write a composable, right? So don't dive in there. I will be explaining everything right now, but let me just explain this basic bit. And this is very important for you guys to understand further in the slides, but this is a very basic concept. So in Kotlin, when you write a function, you write the keyword fun, and then you write the function name, right? So my function name here is say hi, correct? So right now I basically done nothing. I just created a function. I named it as say hi and I opened the brackets. That's all. But you would see there is a composable on the top of it. It's called as annotation. So just to give you a very basic brief, what annotations are in Android, annotations are basically a certain set of metadata or a certain set of data which we use to say the function, okay, this is the thing you need to do. So consider when you use uh, override annotations, or let's say when you were using the butter knife, which is deprecated now, obviously, but when you used to have a certain libraries where you pass an annotation, it can be in Dagger, it can be in butter knife, or any other function, right? That tells that function that how it needs to behave. So that behavior of that specific function, or let's say even variable, right? That behavior comes with that specific annotation. So here in this function say hi, we are annotating it with composable, which means now this function has to render UI. It can be done based on certain conditions, let's say a certain UI set or certain data set which we provide. But the main function of this say hi function is to redraw your UI. So inside this, whatever we are going to write would actually populate as a UI in our Jetpack Compose. So now here comes the second part. So the second part is, you remember, right, that in activity, whenever we had to, let's say, set a content layout, what we used to do is we used to use set content view, and inside that we used to pass the layout file. You can see this, right? Set content view, and inside that, let's say we used to pass r.layout.activity main. But since we are decoupling the whole thing from XML, we are actually not required to use the set content view. So now, in place of set content view, we just use set content. I'll be showing you all of these in the code as well in some time. But my point here is, when you use set content, it requires a composable again. So material theme is just a theme I'm using here. So when I use a material theme, it is also a composable function. And say hi is basically this function which I'm using. So you can see a hierarchy, right? That we have a composable function which says set content. And inside that, we have another composable function of theme. That's optional. That's something I have kept, but this is how you design it. And then we have called say hi. So this is how you set your UI inside an activity first, right? In just a sec. In the second part, let's see how we set it in the fragment. So in a fragment, if you remember, we have to return a view, right? Inflator.inflate, and then we pass it in the onCreate view. So in place of that, you just need to return a compose view. Inside that, you need to pass the context. You can use require context, require activity, and just set the content how you were setting in the activity. So that's how you can do everything there. And inside that set content, whatever you do right now would perform as an activity design for you. And when I say an activity design, it's the same design which you used to do earlier in your XML file, basically. So that's something you have to do here in the set content block. So that's how you set it. Now, let's say that inside the hello say hi function, I have added a text. So just don't focus on the text part here. I've just added text and I've given a value as hello world. So now when I run it, you can see the output on the side, right? Hello world is being printed, right? Now, this is because we have done this. We have set our view there on the set content, and inside that we are calling the say hi function. So the say hi now has a text composable, which composes a text for me, correct? So the text is basically the hello world, right? So this hello world is being printed here. So that's how a composable thing works, right? When you pass something inside a composable, it gets rendered in your view. And here the hello world has to be rendered. So that's pretty much how composable actually works inside you, how to render that UI, and how to do a lot of different stuff here. So do you guys have any questions regarding this? Because if you have any doubts, you would not be understanding anything going ahead. So if you have, you can shoot a couple of questions and I'll try to answer it. So Suvansh, you can actually add dynamic UIs at runtime as well using composable. So that is something we are going to discuss at later stages. But yes, if you need to use dynamic UIs, this is basically a UI based on certain logics. So you need to write that logic and then you can inflate your layouts. So that's what you actually meant, if I'm not wrong. Cool. So I'll go ahead right now. I think everybody understood what I actually meant. So if you remember, we printed something here inside the... Yes, Mansi, the UI is created in runtime whenever you design it. Now, Amol, we are going to discuss this, padding, margins, everything via code. So please bear with me for a certain time. So going ahead, you remember, right? We added this text here inside say hi function. So now here, whatever we write, so for now, it's just a comment, hey devs. But if we write a text, if we write, let's say, an image view, anything, correct? What we are going to do is it would be rendered in an UI. So this UI, correct? So now what is this magic? Like, for example, as a constraint, if I say that whatever we are writing it here, let's say in a text view, how it is getting rendered. So this is that specific magic, right? Which I explained you better, composable. So that composable is telling that specific function, say hi, that, okay, take this function, render it to the canvas. So, or in a better way, if I have to explain, if I understand it better, that if you guys understand canvas, so in a general term, not as an Android developer term, if I have to explain, a canvas for a painter is like his masterpiece, a blank paper, a blank sheet, where he explains you or gives his the best art, right? He designs a certain scenery, a certain thing, and that is being printed at that sheet. For you or for us, in an A4 size paper, when we were in college, we were writing some certain notes. So for us, that paper specific thing was a canvas for us. So here, that Android scheme for the whole Compose is a canvas. So whatever it has to render, it renders on that canvas. So when you annotate a function, say hi, right? Just like this. And we annotate it with, let's say, composable. And in that specific function or on the screen, we render it hello world. So this particular screen, if you can see, right? This screen can be considered as a canvas. And whenever we start designing something, it starts from this position. So this top left corner of your phone is basically 0,0th position. And this is max height and max width position, right? So that's how you actually render it. So when we add a certain composable, let's say n number of composable comes up, it starts getting displayed on that specific canvas. And that's how you do it. So this is the basic magic or the basic feedback or how you use a composable to render certain UIs. So this is something I wanted to cover, but it's totally optional if you guys want to understand it. I'm still going ahead with this. So I'm going to actually explain the whole internal processing of Jetpack Compose. That how does a function gets rendered as a UI. So basically what that specific function does, or that how annotation does, sorry, composable, that it gets rendered as an UI for us. So first, check this say hi function. This composable we used above this function say hi, and inside that we used a text widget, right? So here everything is a widget again. So the text here, and we passed hello world. But when we have to break it down, you still need to have it as a very normal function, right? Because considering coroutines or anywhere else, when you pass a suspend function, it has to break down inside it, and then it passes a certain callbacks, right? Here as well, it has to break down in something else. So the breakdown of that function, say hi, is here on the right hand side of yours. So inside this, you can see inside the compiler time, you would not see the composable annotation here. Rather, you would see two different values being added here. So this is not a parameter though, but it's a break time of this function. correct? So consider this use case here, that this say hi function had a composable. So this composable got broken into a composer and its value. I'll be explaining what this value is, but for now, consider this composer. Okay, so in this composer is basically like your paintbrush. Okay, and a paintbrush is basically like, in this function, whatever we have to actually paint it out on the UI. So this composer takes that brush, design this text, and starts designing it. It sees if we have any other composable inside that function, which we have text, right? Then it passes that composer to that as well, and then it ends it. So basically, first it renders it say hi. It takes that composer. Inside that say hi, it starts the function, and it starts designing this value, the composable text. And when it's done doing it, it ends it, composer, right? So that's how a composer works. It's basically like a collection, I would say, or like a hash map, where all the composable are stored, which has to be drawn. So here we have, in this function, we actually have two composables. One is say hi, which we have created, and another is text, which basically provided by Jetpack Compose itself. So now here we have two composables, right? So it has to be stored somewhere to understand that this is a composable, right? So when we break it down, this composer actually took this say hi function via this composable annotation, and it started designing all the children layouts. So the children was text. So here it started composable.start. Then inside this composable, text composable, it passed its own composer and a newer value. And then it designed this text. And then when it was okay designing the text, it rendered it and ended the composer. So now this 500 and 400, let's see this. So let's say in the collection, or let's say consider a hash map. So how it is built, right? Think this composer as a table basically, and this 400 is like a hash key. So if you know how hash table works, it is basically mapped to a key and a value. So this hash key is basically the key where the composable has to store, and that is basically known as composer. So that table is basically a composer here, and this is how you would look. So the composer is basically nothing, a data structure which we call gap buffer. It's basically like a hash map where we store all our composables at a certain address. So let's say we have 500 and 400. So I stored 400 and 400, but here it should be 500 and 400. The reason being is it needs to store at that specific value, right? So here we have two composables. One is say hi and another is text. So we have two composables which we need to store in this composer at this particular location, 500 and 400. So here will be 500 and 400 here, and it would store that like this. And this whole table is known as composer. So this gap buffer data structures helps us to map all the composable which has to be drawn in our UI, and we have to do a certain aspect of task whenever we have to render that UI. So that's how that composable function or annotation per se actually works very much internally to design that UI on your screen. So that was pretty much for the theory part I had. I would be explaining a couple of more theories there, but now we have to see a certain set of amount of code. So we have to go through a very faster set. So if you have any questions, I'll love to take it, one or two, then I'll move down to the code side. So basically a single composable function is like a composer in itself. So it's not a hash map, it's gap buffer, but each composable is pretty much similar to a hash table, if you have to consider it that way, Ratul. It's just like still in alpha, so it might change in future, but for now, it works on that gap buffer data structure. Hitesh, answering your question, it would be a nested tree. So like if you see this code right now, we have a text, but here we can have another material theme and another text. So like this, if I have to just copy this and I have to show you like this, right? That it might have a multiple different layouts. a nested one. So this is how you have to do it, like how let's say in Flutter we are doing it or something else. But if you have to change it, let's say you have to change, right? What you can do is you can modularize this. You can have a composable here and you can write it in a different file. Then you can have each composable written differently, like how we have a separation of UI, and you can just keep on adding it. So that's a better way how I try to manage. But if you guys can see a better way, I would love to hear that part as well. So I think I'll move ahead with this thing. So for now, I'll start off with the basic code. So I hope everyone is like able to see my screen, the font size. If not, I'll just increase it by a bit. If let me know if you want a bigger text size. So basically, I have added a couple of UI dependencies here. Jetpack Compose UI tooling foundation. I'll show the UIs as well. So there you go, the dependencies. This is my dependency which I have added. UI tooling and every other stuff which we needed. And for now, for this session, the version we are using is 1.0 and alpha 6. Correct? So just let me show you the basic overview first, and then let's complicate things. So if you remember from my previous slides, this is how we can actually set a content in an activity, correct? So I have used set content. Inside this, I'm passing material theme. So if I just go to set content code, you can see it requires a composable function, correct? So in this, material theme is itself a composable. So that is the reason when we are passing in set content, we are passing the composable here so that we can render this material theme function inside here. So now what I have done is inside this set content, I have created a material theme and have just passed text, correct? And let me run this to show you what happens. So you can see Himanshu being printed here, right? So this is a text which I wanted to print, and I have printed it successfully, right? How I printed hello world in my slides, right? Now let's do certain modifications. So I was actually planning to do it here, but now since Hitesh has asked, I'll do it in a separate complexity. Like I'll try to make it easy. So let's say I'll create a function. I'll name it as set text for composable, right? Now I'll annotate it as composable like this, and I'll make it a basic function. Now I'll remove this, and here I'll call the set composable here like this, and this should work fine, right? Let me run it to show that this Himanshu would be disappeared, correct? Because you're not setting any text for now. So now if you need to call any widget here, you can use a certain different options. But now what I'm doing is I'm going to use text. So now you can see there are text. If let's say you want to load an image, you can use image and a lot of different things which I'm going to explain it to you. But for now, let me just call text. And in text, I'll pass Himanshu. And let me run this to show you that what previously we were doing it here, we can do it using the set composable, right? Now, as a next step, let me just change the design, or let me change the color font first, right? So I'll change the color. So to see what all properties a certain widget gives you in Jetpack Compose, just open the code for this text. You can see a lot of different options are provided. So I used text for now. I would be using size, I would be using style, and a lot of different properties, right? So you can see a lot of different things here, correct? So here I'll pass color is equals, and for now I'll use, let's say, color.blue. Let me run this, and I hope this should change to blue now. And you can see the color has changed, right? Now, let's also make his text size a bit large. So to make or change the style of basically text, I'll use style is equals, I'll open an object for text style. So now to set certain styles, you can use text style, and inside this you can use font size, font weight, font style, and a lot of different style, right? So I'll use first font size is equals, let's say I'll put 16 sp, right? But you can't use 16 sp how you used to do in XML. So to use that specific unit, you need to pass 16.sp, and you need to import this dependency, and it is done. So basically, let's say if you want to use sp for font, you need to use .sp here. And if you need to use, let's say, dp, which we should not for text, but I'm just showing it here, you can use dp like this, .dp. Now let me run this to show you how it looks. Sorry, let me just run it. Okay, let me increase the size maybe. So you can see when I increase the size to 60, it's changed its size, right, Himanshu? So now it's a bigger font with a certain designs, right? So now if I'm not wrong, somebody asked how we can add a lot of paddings and all, right? Amol was the one who asked. So to do certain changes in the UI designing, like let's say if I want to make it match parent, if I want to give a certain padding or something, what we basically do here is we have certain property called modifier. So modifier you can consider in a very basic and a layman term that it's a CSS for Jetpack Compose. So using modifier, you can do a lot of different property styling. Let's say I want to use modifier dot fill max width. So now what this would do is this would take a match parent for this, right? Just to show you, what I'll do is I'll see if I can have a background property here. So for that, inside that, what I'll do is to set a color, I'll use background dot color is equals color dot gray, right? So I'll run this to show you that I just have a wrap content for now, which you can see I have a wrap content. And if I want to make it match parent in the width, I'll use fill max width, right? And I'll run this. So you would see now this has taken the full width now, and using this function or maybe an extension function, we can use the match parent, right? So this is one of them. Now, considering that we want to give a certain, let's say, padding to it. I want a padding here from 16 and from top as well. So for that, we can use dot padding. And here I'll pass 16.dp. So what this would do is it would give a 16 dp padding from all the sides, top, left, bottom, and right. But if you want to do just from top, what we can do is we can pass the property top and we can pass 16.dp like this. So let me show you how it looks. You can see we have a 16 dp padding from the top, right? So let me remove this top property here and let me run just to show that we have a padding right now from all the sides. So now you can see this, right? It has a padding from left, right, top, and bottom. That's how you can do it, correct? That's a way to do it. Now let's say that I want to perform a click listener to this text, correct? But if you see the code here, you would not see any text on click listener. That's not something which has been provided. So to add a click listener to anything, you can use inside the modifier. It is known as clickable. So inside that clickable, what you get is you get an on-click function or on-click lambda, right? So inside this on-click lambda, what happens is I'll just pass on a toast just to show that this is actually working fine. Now I'll run this. Now if I click this, a toast comes up, right? This works fine. This one, correct? And now you can see that ripple animation coming by default. because now we have added this clickable to the modifier, and this works perfectly fine, right? So this is how you can do a certain changes to a specific property or a composable here, right, using a modifier. A lot of different other properties are, let's say that I want to change the font weight here. So I can pass font weight, and I can use font weight dot bold. Correct? Now let me run this. Let's see what happens here. This whole thing actually becomes a bold, right? So that's how you work with composables or here. So let's say if I add 3 different composables, right, it would overlap each other. So if I show you this code, you can see nothing comes up here, right? Because everything is overlapping each other. Now let me just change, let's say some parameter here, or let me just create a new composable function, just copy pasting it. I'll name a random text here, and I'll just change the function name here. And in place of these two, I'll just add this test. So I'm doing it quickly. The reason is I've shown you how to do it. So I'm just copy pasting it, and I'll run this. You would see this comes first, right? The reason is whatever we have overlapped. So this is overlapping, but the background is filled with gray. So this function is also rendered, but this function comes on the top, right? So this is how you can work with composables, and we can use set content or material theming just to design your UI. So that was a very basic use case, how I was explaining how to do it. So do you guys have any doubts, or I can go in deeper code, how to show you how I can write more extractable codes and how to show you a more different set of codes here. So if you have any questions, I'll just take it 1 or 2 and I'll move ahead. So Malika Arjuna, yes, you can use composable with architectural design and development, like a lot of things. I have a project with Dagger Hilt, Clean Architectural MVVM. So you can check that out on GitHub. So I'll be showing that once right now in this state. So just bear with me again. Sorry, I'll be explaining that. Cool. So I'll start the next part of it. So in this part, we actually saw something which was a very static set of data, right? A text view would not have its own state. And when I say state, it is very familiar to React guys, like managing a state. And now Kotlin guys are actually talking about states as well, right? That we do this in state, we do that in state. But what is an actual state? First, we have to define that. So let's say state is certain set of data which would hold a value, correct? So consider state as a container which has a value, and when rendering it, right, when you render a certain set of value or a composable, the initial value from that state is used to compose. Then when we change the data of that state, what the state does, it actually goes to that specific place where the value is used, and it recomposes itself again. So consider this text view example, this one, right? If it would have in a state, let's say I'm just giving a demo. Let's say we have a function called state, and it has Himanshu here, right? And I just pass the state here in the text. It should work fine, right? But it has a constant value of Himanshu, which is not changing. But let's say if we are changing it, but we can't update the value here again and again. The reason is once it's composed, like using this composable, first time when the onCreate is called, we can't recompose it. So we want to recompose based on the value what comes up to the state, right? If I'm not wrong, that's what we want, right? That we want to change the UI based on a later set of designs. Like us, let's say, consider this. When we create an edit text, we have an initial value of empty string. But at a certain stage, when we do that edit text dot get text dot to string, we get a very basic set of value after writing something in XML, right? But when you do that in Compose, what the problem becomes is that when the screen was rendered, it had an empty value, no matter whatever you type there. But when you want to take that value out, let's say that edit text dot get text dot toString, it would still return you an empty value. But because the initial state, the initial value was 0, whatever you typed there, it didn't change the value. It didn't change the state of that edit text, right? So basically what happens, consider this. I started typing in the edit text. I fired an event. That event goes to my state, which gets a newer set of values, and it starts recomposing that specific part. So, okay, if I go back to this code again, when it has to recompose, let's say I have another composable here, and this only composable is managed by a state, correct? So that specific state would only change this composable. It would not change the other widgets here because that state was actually mapped here, right? So now let's understand the state concept in composable as well, how we're going to use it. But I hope this concept was clear to you. That only state renders the UI, and when the UI renders it, the state changes. Consider in the edit text, right? When UI changes, like after adding certain text, the state changes, right? So that's pretty much how I have to explain state. Now I'll show you this in the code. But if you guys have any other suggestions, just let me know. I'll go through it again. Because state is a very important concept you have to remember in Jetpack Compose. So here you need to have a very constant static file, I would say, where you can pass on the dimensions or your strings. You can still use strings and .xml to get the strings, but for dimensions as well, you can have either a constant value or you can use the dimen.xml file again, just to pull off the data. You can use that. So fine, I think no one has any sort of questions, so I'll move ahead. So I'll delete this for now. What my next task is, I want to create a function which renders me a login UI. I want to show a login UI, how it looks, right? So I'll create a function again. I'll name it as, let's say, login UI. And I'll annotate it as composable. Correct? And inside this, what I want to do is, first I want to have an edit text, right? So for edit text, I want a text field. So my design would be edit text and then a button, correct? So I want it in a linear layout in a vertical orientation. So to have that, we have something called column. So column does basically, it creates a vertical layout, correct? In a vertical layout, in an orientation of a, in an orientation how linear layout used to do in vertical thing. If you want to do a linear layout in horizontal way, you can use row. But since I want in a vertical way, I'm using column. So here I'll have first a text field. So here a text field is basically like an input field, an edit text, right? So it requires an initial value. So the initial value would be this, an empty string. And in on value changed, we need to call a function, right? So let me just show you how it looks, so that you guys have a very basic clear idea while we are building it. So now we have an input field, right? You can see we have certain things, but you can see whatever I'm typing, it doesn't get rendered here because the initial state was empty and it sticks to it, correct? So now we need to actually render the state. So for now, for creating a state, we'll have, let's say, email state. And to remember that state, what it was in, we use actually a remember keyword. So that's pretty easy, that you need to remember what state it is in, correct? So we need to remember the state. So we'll use mutable state of empty string, right? So either you can pass it here, something like this, how you do it for string and all. But I just don't want to pass an individual specific type. So I'm passing an empty value. And here I'll pass email state. And in the value, I'll pass email state dot value, correct? Inside this, what I'm going to do, on value change, I want to upgrade this state's value with the value I'm adding, right? So here I'll use email state dot value is equals it. Now let's see what happens. I'll explain what happened here right now. So now if I try to type something, it should update, right? So basically what we are doing here is, first we set that initial value, which was an empty string, obviously yes. Then we were changing the value. So it's basically like the text change of edit text. And when the text change happened, we updated the value of email state. And since we updated the value of email state with the latest string we had, the state got upgraded to this state, and we have this, right? So this basically it, what we wanted to do. Now, let's say that we want only an input type of email, right? So when you have an input type of email, you get an @ symbol here when we do it in edit text. So here as well, if I need to do it, I'll use keyboard type. Just a second. Keyboard type is equals keyboard type dot email. Now let's see what happens when we run it. Now you can see @ coming here, right? Because now the input is @ here. So that's how we actually put it, as in this, right? Now let's add a button as well. So I'm going to add button. So to add button, I'll just use button this. I'll have that click list now. And inside this scope, so basically you can see there's a row scope. So now if I add a text here, let's say text, I'll pass, let's say login. Let me render this as well. Let's see what happens. Now you see a button as well coming, right? A login button, and the click listener is happening here. So now, since we used a column as a container, as a view group, I would say, then it has rendered it in the vertical manner. So just for a testing purpose, I'll use the row. And if I run this, you would see it would come in an horizontal way, right? So this is how row works here. Now let's do a couple of changes. Let's add back to column, and let's add certain margin to it, correct? So what I'll do is, first I'll add a modifier here, because we need to do the CSS styling here basically. So first modifier would do is modifier dot fill max width 10. That's done. And I'll add a padding, let's say of 8 dp. So I'm now going a pretty fast way because I've explained all of these to you. When I run this, you would see now it has a full width and with a padding. Similarly, I'll add a modifier to this as well. All the composable should have a modifier. So this as well, I'll have a full max width, and in this as well, I'll add a padding to 8.dp. Let's run this to show how it looks like. So now this is the basic thing, right? This is what we wanted to build. So that's pretty much what we wanted to do. Now, what happens sometime is we actually, in the login form, in the production level form, we have an email icon here, right? So to just show you how we add an icon, I'll just use trailing icon, which means it should be trailing here. And here I'll have to pass icon. So basically what happens is, in Android or in Jetpack Compose per se, we have a lot of dependencies which just provides you the icon. So if I show you the dependency Gradle, you can see we have icon core and icon extended. So basically these dependencies are responsible for providing you icons by default. So here to pass on an icon, I'll just use icon. And inside this, I'll use icon. Dot filled dot let's say email. Yeah, they should work. So you would get an email icon here if you say this. So you would see an email icon here. You can see this input type is taking, let's say, this @. Basically, the input type is of email. And now, at the last click, what I want to do is, I want to click this login to show a toast of this text what we have entered. So for that, this state comes into the picture, and this state is very important. So now, since we are upgrading this, let's say I'm upgrading certain things, right? So what it does is it has the value in this state. So now if I want to show the toast how I showed it earlier, I'll use make text. I'll pass this. And here I'll pass the value, email state dot value. And now I'll pass the duration and all. So that's basically normal things we have been using. Dot show. Right? So this throws an error because this requires a context, but this is actually providing the context of this column. So I'll pass the Kotlin way, this at the rate main activity, so to be sure, and I'm just running this. So let's see what happens. So if I enter certain text, if I press this, you can see a toast coming up, correct? So that's how you can actually design a much complex UI in a certain way, correct? So this is how you do it. Now, hovering back to the question Hitesh asked again. So let's say this is a login field with only 2 text, right? But this much code we have written. But consider this. At a certain point, we might need to use button again. We might need to use text field again. So what we can do is, I can also create a composable, let's say, function my button style, right? Which will take a text. So I'm basically creating a generic way to create buttons, right? And inside this, I'm going to pass it, right? Now this state can be anything, right? So for now, it's just a toast. So I'll remove this as well. And I'll have a lambda function. Let's say I'll click a lambda on click. Unit. And I'll call this inside this on click function, and I'll pass this text here, right? Now, what I can do here is, this is for Hitesh specifically, and that's like, I can just call my button style, and inside this click, right? What I can do, I can just call my toast, right? And for this text, if I have to show, I can use a specific text of login. So now this is how I manage my different set of composables here. So now this function can be used at multiple different times, but this login would still perform it because now we have a composable for only a button style, right? My button style. So this function I'm going to call again and again. Now this set of code has been reduced to only 3 lines. And similarly, you can do that for the text fields. So that's pretty much how we can use it with the composables, and we can understand the states. One last thing which I actually wanted to explain you more is, let's say I'm just minimizing this, right? And in place of this, let's say I want to create a list. So what I have already done, I have created a faker source, right? Where I have a list of data, Himanshu, Recro, and a lot of different mock sets, right? And I have a main view model. Inside this view model, what I'm basically trying to do is, I'm passing a live data. So I want to show you as well that how I can use this view model with composables. So that's the goal here right now, what I wanted to do. So what I'm going to do is I'm going to call this mock list. So this is pretty self-explanatory. So I'm not going to explain. I'm just setting the data here. So inside this, first I'm going to declare a variable. I'll name it as, let's say, view model. It is of type main view model, and this would be main view models, right? So I've declared my view model. This is an extension which we use, correct? And let me delete this. And if you see in the view model, we have an init function. So what this init does, it starts giving me this mock list, right? So I'll just call this view model dot init. There can be a better way to do it, like how we do in activity, but this is just a demo or template I want to use it. So in the on create, I'm calling this init function of the main view model, right? Now, what we basically do is, we do main view model dot mock list dot observe and a certain set of code, right? Which we are not going to do here. What we are going to do is, we are going to use this view model to render the data as a state. So since I have explained you what states are, right? So I'm going to use that as a concept. So here as well, I'll create a composable and I'll pass a function, let's say show list. Now this will take a view model as a parameter, right? I can directly use this view model here as well, correct? And do mock list, but I don't want to do it. For your purpose, I am adding this to my main activity file. But at a certain space, I can use this here. I can use list composable. And I can just use this function, let's say here. And now I would not have that access for my main view model, right? So I'll just use it here. So I'll pass main view model here. So now what I want to do is I need to display this list of strings in my recycler view or in a list. So something which we want to catch up here is that if we need to have a rendered list, a recycler view in composable, it is known as lazy column for. Correct? So this is the one line, lazy column for, and here inside this you need to create the items. So first we need to pass an item here, basically let's say this. So either I can just pass this, let's say mock data for now. I'll just show you how to do it, right? And this will return me an item in the lambda. Now I'll just pass text and here I'll pass item, right? So I'm not using this view model for now, but what I'm doing is I'm just passing that mock data from my private source, like from the faker source, right? So for now, just hold with me for a sec. I'll just explain you. I'll call this show list function here, and here I'll pass the view model as a parameter. I'll be using that on a later stage, but for now, I'm just passing that mock source here, just to show you how does that look in the UI. So we have rendered our list here, correct? So let me just copy paste this to show you a list, proper list. I just copy pasted it just to show you a longer set of string. So you can see the scroll is happening here, right? So this is very much similar how a recycler view works in Android. Now I'll remove this. What I want here is I want to get that data from view model. So in the view model, we have this mock list live data, right? So we are going to use that. So first I'll use, let's say, mock state. So first we need to convert this live data to a state. So to convert a live data to a state, you'll use view model dot mock list observe as state. So what it did was it converted this live data to a state, right? So this is an extension function for this live data, if you can see here, and it converts it to a state, correct? So that's one thing we need to do, correct? So now we can't directly pass mock state here because it requires a list of type, right? You can see this, a list is required, but we are passing a state. So now I'll do is val list is equals mock state dot value. Now, if you remember in our main activity, inside this as well, we were getting email state dot value, basically giving us the string. We'll use this list because we passed mock state dot value. Now this throws an error, right? Found type variable or something like that. So the reason is in observe state, it gives you of type nullable as a return value. So we need to put a condition check or let. So I can use condition check that is null or empty, and it should not be that, right? So that error is gone. So what I'm doing here is if list is not null or is not empty, then just print this. So let me run this again. The same thing you would see as an output, right? So what we did basically here was we converted this list, the live data which we are passing from the view model, and we converted that to a state. So to convert it as a state, we used view model dot mock list dot observe as a state, and we observed it as a state. Then we got its value using state dot value, and we assigned it to a variable list. Then we check if it was null or it was empty. If it was not empty or null, then we just displayed the list here using the lazy column for. Now let's say if you want to get an index of this item, right? So you can use lazy column index, and here you can get index as well, right? So I'll just show you if we are getting it or not. So I'll use index.string.item.item. So I'll just run it. I'll just show you how it looks like here. So you can see the index is also coming fine, right? 0, 1, 2, 3, 4, and we are getting it like this. So this is one way to do it, like creating a list, and always running this to see how this looks like, right? This is a very smaller project, so that is the reason we are actually able to see it, right? Correct, again and again. So now let me show you a very basic way how we can do it again and again. So let me create another. So let me create another function. I'll use it as set text value. Again, it's a very basic thing, right? Inside this, I'm just going to call text, and here I'll pass Himanshu. So one of the ways what we are going to do is we can use here and we can just run it, correct? And this would print Himanshu for us as an output. But we don't want to do it again and again, right? We just want to see how this function looks. So for that, we have something called preview annotation, right? And you can see this coming up here on the right-hand side of your Android Studio. So you can see Himanshu comes up here, right? So let's say if I run Recro, then it is refreshing the preview. Let's see if it refreshes or not, because the point here is it always runs, it is always buggy because it is on your canary build. So you can see Recro coming up here, but the preview is still Himanshu here, right? It's not updated as of yet, but now it's updated to Recro. So that's one of the ways to just see without running how your UI looks like. So using preview in your canary builds helps you just to see your UI. Now to this, I can show how it's compared to a traditional view. Like a couple of questions were asked just to show in a traditional view how it looks like. So consider this. This is a text view XML which we were using till now. Wrap content, hello world, and let's say color white and this, right? So this is something we were using. Now in functions, you can just write this certain set of codes, and that's it. That's only thing you need to write, right? That's one thing. Now, considering a recycler view, when we do a recycler view, we first declare it in our XML, then we bind it with our activity, and at last, what we do is we use to pass that data to adapter, and that adapter passes to view holder. View holder again binds it with an item. So basically, a lot of bloatware codes, correct? A lot of codes. This is what we did in Jetpack Compose. We just used lazy column for, we passed that item, and we designed our UI. That's it. We didn't have to do a lot of view holder pattern stuff, and that just worked perfectly fine for me. So that's basic comparison, how you actually do a lot of different stuff here and there. So that's how I have been doing till now. So coming back to this, I am basically done with my session right now. But if you need to check for resources, the official resource is this, the developerandroid.com jetpack/compose. One of the architectural patterns I have used for a project is compose pictures, which I have built. It has what do you call that, pagination and a lot of compose pictures, pagination list. It has a grid view design. It has state management, multi-layouts, navigation components. A lot of different stuff are there, but this is, the UI is built using Compose. So that's another. And if you want to learn step by step, there's a guy, Vinay Gaba. He has made this repository, Learn Jetpack Compose by Example. So this is another way how you can learn it. So these are basically resources if you want to get started. And if you get doubts, definitely I'm available on my Twitter handle. Just tweet me for any questions you have. That's it, guys. Thank you so much. Thank you for being such a lovely audience. And now I would take your questions. So on a performance side, Hitesh, I would say I find it a little bit faster compared to XML. But that again, how we design it, I would say, because the reason is uh, we can actually combine it in a different aspects. Like constant layout also solves that problem. This also solves this problem. This is more of declarative UI, how you need to use compose again and again just to use your function set of codes to design your UI rather than going there. So I found this to be faster, but since it's in an alpha stage, a lot of issues comes up. So that's, I'm waiting for that production build to be ready. Then let's see what happens. Mihir, yes, you can actually do it. So one of the ways I did was I created a custom view. How we did till now in Android was we used to extend a certain view group or a certain view, and we used to design a view, right? So what I did here was I extended a frame layout. Inside that, rather than inflating a layout, I just wrote that Jetpack Compose code, and I just imported it as an XML. So that's something I actually worked with. So maybe that's how we can combine. It's not a flat hierarchy frame, but it is a nested thing, but it doesn't has to do recomposing again and again, like the redrawing which we used to say in XML thing. So that's why it is performant enough. It's not flat, it's nested. If you see the code here right now, in the login UI, it's nested, right? We have first a set content, then material theme, then a text value. Let's say if I pass the login value, inside that we have column, then we have a text field, and inside that we have a lot of different properties. So it's not flat, it's a nested tree. Rohan, yes, we can do it. If I'm not wrong, we have something called constraint layout. There you go. I can share you that example as well. Just ping me on Twitter and I'll share that example. I have that code written for somewhere using Jetpack constraint layout and constraining it with different views. So I have that. What about orientation specific UI like layout? So that's something I have not explored, frankly, but it could be done, because if you are doing this, let's say column, you need to define two different states, right? It has to manage both of the things. So now if you want to design a certain aspect of a code, you need to design for both layouts, and then you can use it. Can we get rid of themes in XML as well? Yes. So in this, the theme has to declare in a Kotlin file. So just a second. If you see this resources compose picture here, the theme has been actually defined in a resource file. Sorry, in a Kotlin file, not in a resource file. You can design a lot of shapes, like how you can do it in material components. So that same things can be done here as well in the shapes. I think I've answered your questions, Jobin. Yes, Hitanshu, I actually think we can replace it, but I prefer personally to keep individual screens in individual fragments. I would say like that, because just give me a moment. Because I have done it somewhere, because I don't like doing it again and again. So I have kept it single separation concerns again and again, so that what happens is, if let's say it's an edit profile screen, for example, the composable has to work for only edit profile. It doesn't have to be exposed by other modules or other activities. So let me just show you once.
Hi guys. Meanwhile, I'll be sharing the deck link with all of you. So this is the deck link, and you can see all the code here.
Yeah. And coming back to Hitanshu, see this code for once. So I have this edit profile fragment, and here I have just created my themes, and I have passed on my own composable edit UI. Now this edit UI, I have declared it somewhere else, and this is how I have written the code. So this edit UI is not responsible for getting accessed by another module. So this is how I have kept my fragments. So if I show you my project structure, these individual modules are my individual fragments. So I have kept the separations differently, but we can do it. Yes, in one fragment, you can have 3 different profiles, but the performance, the navigation to and fro, you need to handle it very cleverly via navigation components. That's something, it's not yet evolved properly, but you can do it.
So the next question that we have is advantages and disadvantages of the Compose?
Okay. So advantages is you don't need to explore XML. My favorite part. Another, just you can start writing Kotlin if you know it. Disadvantages, again, you need to write with Kotlin. I don't see any other problems. Still, it's not stable because a lot of crashes might come up because it's in alpha. But apart from this, I don't see any disadvantages of using Compose. In future, Kotlin might actually switch, like how Kotlin became the first choice language. It might also become your first choice UI toolkit, replacing XML. It might become.
I
Any other
hope,
question?
Amol, your question has been answered. You can reply us in the chat. All right. So, guys, we also have shared the deck link, which you can like download. It's a PDF file in which you can see all the things we discussed here. Along with that, we you can also follow us on Instagram and LinkedIn, as well as we have the YouTube channel where you can like revisit this talk. We'll be uploading this whole talk there as a screen recording, and you can also follow Himanshu on LinkedIn, and you can also follow me on LinkedIn. And if you have any questions, we can connect there always. Also, you can write a feedback to the stock in the feedback link that I've shared you with all of you in the chat. So if you guys have any other questions, we can answer them. Like we have like 5 to 10 minutes of our time left. So if even if you have some doubts regarding how it will be like used in different architectures, even that can be asked. And
Yes, and one more
any
thing I have to add, like you can use Jetpack Compose like with coroutines natively. So launching composition is by default present there.
so someone is asking about what about UI testing?
So the testing is possible there, but I didn't keep that session for now in this. So I would share in that project, I'm going to add the UI testing as well. So you can add something else. So it's not espresso testing, but it is the compose testing for them. So that would be available there.
Okay.
But it's not fully functional as of now.
So I think there are no more questions, and
Right.
yeah, I think it was a great session on the latest Jetpack library Compose and the UI toolkit. And I thank you, Himanshu, from the team Recro and from all of our attendees to guide us in the right way on how to start using the Jetpack Compose. So yeah, like big cheers
Thank
to
you.
you, how you explained everything. And yeah,
I
thank you
think it
for
I
thank
think it
you to
went a
the.
bit fast, but it was okay. People can actually slow it down to understand.
Yeah, like the screen recording will be the
Yeah,
screen share will be the recording will be available on our YouTube channel, which for the and the link for that I've shared it on the chat. I'll share it
sure.
again so that everyone can go there, and you can also like see all our previous talks on Android and different platforms and frameworks that we do. So yeah, like it's better to go there and check the previous talks also. And I
Thank
thank everyone on the like every attendee to join this amazing session on and learning new things. Yeah.
Cool. Thank you,
So,
Sarthak.
yeah. So would you like to have like a uh, end suggestion for anyone like here, like how to go about it and start using it,
No,
or
as such,
should
I don't have any other suggestions. It's just like it's like a swimming thing. Just deep dive into it and just
yeah,
start learning. Whatever you find, you'll just find it the hard way. But at least you have to try it out to understand.
yeah. So, do you think when do you think we can start using this kind of libraries in production codes, or should
So
we refrain from that?
at least I would not recommend using it in a production level site.
Hmm.
It's a good one for a side project, but I think by summer next year we should have a stable version of Compose. That's
Okay.
what Google team is working towards. So I hope they work and they get us this one because it's a very good thing to get started. I hate
Yeah.
XML
Yeah.
personally, so
Yeah. exactly. All the complications that XML creates, and yeah, like
Right.
you can directly use for loops and like the coding structures that you have in the Kotlin, you can use directly
Correct.
in this here, which you cannot use in XML. And yeah, like this is like it is quite similar to what React and Flutter.
Correct. Correct.
Yeah,
Okay. And one thing I definitely have to add here, I think I missed. You can use Jetpack Compose to write Kotlin multi-platform code.
which is the Kotlin native that they
Yes,
have.
yes, yes, the Kotlin native. So you can use Jetpack Compose to write multi-platform architectures as well, because it's Kotlin based. So you don't have to like write an XML native code again and again. So that's a good thing, I would say.
Yeah, reusable code is always
Yes,
better than, yeah,
correct.
writing it in different frameworks. So yeah, I think we can call it as a wrap. And yeah, thank you, Himanshu, for giving us a beautiful talk on this Jetpack Compose. And
Sure,
thank you to all the attendees for joining this session.
sure, Sarthak. Thank you
All
so
right,
much.
bye bye.
Bye bye.